Hello all and welcome to a video answer key for your elements, compounds, and mixtures drawing practice 1 assignment. So in this slide you're asked for a pure substance of diatomic compounds. So a pure substance means that all of the molecules are going to be the same. Every molecule is a different chemical, and a pure substance means you've only got one chemical or one substance present. So you can see all three molecules are the same. That makes it a pure substance. You're asked to include diatomic compounds. So diatomic means that you've got 1, 2 atoms in the molecule, and each of them have 1, 2 atoms in the molecule. And compounds means that each molecule, or a compound, is a molecule in which the two elements are not the same. Okay, so there's one element here and another element represented by the darker circle. So that makes each of these a compound because each has more than one element. They're diatomic because they have 2 atoms in them, and it's a pure substance because all of the molecules are the same. So if this was a microscopic view of the containers of a contents of a container, then like a jar or something, or a sack of sugar or whatever, you would only have one type of chemical in there. It would be purely one thing. It is not a mixture. Diagram 1 in this assignment asks you to show a pure substance of diatomic compounds. So pure substances are materials, or maybe the contents of a container, like a jar of something, or a bucket of something, or a bag of something. But whatever you're looking at, if it's a pure substance and you could see the molecules that make it up, you would see that all the molecules are the same, because every molecule is a different chemical. So if you have a pure chemical, like pure sugar or pure water, that means that if you could see all the molecules inside of that container of, let's say, pure water, all the molecules would be exactly the same. There would be no other chemical in there, and every chemical has its own specific molecule. So this makes this a pure substance because all the molecules are the same. You're asked to show compounds. So we have compounds here. Each of these molecules is a compound, because compounds are molecules that consist of more than one type of element. So you've got whatever the white element is there and the black element. Those are 2 different elements. That makes this molecule a compound. It's a pure substance because they're all the same molecule. And you're asked to show diatomic compounds. Di means 2. So there's 1 atom, 2 atom in this molecule. That makes it a diatomic molecule. And in this case, it's a compound because you have more than one element. Okay. Next, you're asked for a mixture of monatomic and diatomic elements. So this is a mixture because it's got 2 different types of substance or chemicals in it, whatever this element is and whatever this molecule is. Those are 2 different chemicals, so it's 2 different substances mixed together. That makes it a mixture. You've got monatomic elements, and monatomic means 1 atom. So here's our monatomic elements. And diatomic means 2 atoms, and it's a diatomic element because the two atoms in the molecule are the same element. Okay, so it's not a compound. You call that type of molecule that is not a compound a diatomic element. It's just 1 element, 2 atoms. Cool. All right, so for number 2, you were asked to show a mixture of monatomic and diatomic elements. So it's a mixture here because unlike the first diagram, you have 2 different substances or 2 different chemicals in this view. So again, you have to visualize that these diagrams are a microscopic view of, let's say, an object, maybe the fabric of your shirt, or the contents of a container, let's say a jar of something, a bag of something, whatever. But if this is what you would see when you looked at an object or a substance through a very powerful microscope, if you saw that you had different chemicals in that substance or object, you would have a mixture. And this has 1 type of chemical and a second type of chemical. That makes it a mixture. Okay. It says a mixture of monatomic and diatomic elements. So monatomic means 1 atom. So here's a monatomic element. And then it says diatomic element. So this molecule here is diatomic because there's 2 atoms in it. Di means 2, like bicycle. The di is the same prefix. So you get 2 atoms in the molecule, and since it says it's an element, that means this is not a compound. This is a diatomic element because whatever that white element is, you've got 2 of them, diatomic element. It's not a diatomic compound because you've only got 1 element, diatomic element. Okay, so it's a mixture of a monatomic element and a diatomic element. Moving on. All right, so number 4 asks for a mixture of compounds, and because it's kind of general, your sketch may be different than this one. I just picked a diatomic compound, so these two right here are diatomic with 2 atoms, and they're a compound because it's 2 different colors, 2 different elements in the molecule. And then this is a different compound because this one's triatomic with 3 atoms, and again it's a compound because you've got 2 different elements in there. Okay, so that makes it a mixture of 2 different compounds. There. All right, next you're asked to show just a mixture of compounds, so your answer could vary very much from the one that I have here, but you should look at your answer and see that you've got one type of compound, which has to have at least 2 atoms in it, and at least one of them's got to be a different color from the others, so there's one type of compound there. And since this is a mixture, we need a second type of compound, as it says compounds up here. So this is a compound again, because it's got more than one element in it, white and black, and I just made this a different compound by making it triatomic. You didn't have to do triatomic. You could have done 2 different diatomic compounds, as long as you showed different colors. And I showed a dark here and a lighter gray, so maybe that worked for you too. Okay? But it's a mixture because the molecules are different, and it's compounds because each of the molecules has more than one element. Moving on. That's a... We'll skip the repeat. Oh, darn it. I have to trash the whole... This is 5. Okay, moving on. So this says a pure substance that's monatomic, and this one's pretty easy. It's a pure substance. All the molecules have to be the same, or in this case, the particles, because we don't have molecules. But all the smallest chemical parts have to be the same, so it's the same chemical. And this is. And monatomic just means one atom. So this could be a diagram of, for example, like neon gas and a neon light. Neon is a monatomic element. And if this was inside a neon light tube, like you'd see in a storefront or something window, then that means that inside those tubes you've only got one chemical. You've got only one type of substance, and that would be this monatomic element, which could be neon, for example. 6. Wait a minute. 6. All right, so now we've got a mixture of triatomic compounds and diatomic elements. So again, in a mixture, we should have different types of molecules, which we have. Okay. Triatomic compounds means you've got 3 atoms. That's what triatomic means. And here's 1, 2, 3 atoms in our triatomic compound. This is a compound because it's got more than one type of atom or more than one element in it. So compounds will always have at least 2 colors that make up that sketch of that diagram. And that's a compound because of that. And it's triatomic because there's 3 atoms. The next part of this mixture is a diatomic element. So here's a diatomic molecule with 2 atoms, and because it says element is singular, that means we only got one element in here, it's not a compound. So here's our triatomic compound, here's our diatomic element, put them together and you've got a mixture of 2 different chemicals, whatever these 2 chemicals are. So that's a mixture. 7. All right, now we have a mixture of triatomic compounds. So this is a little more specific. You've got to have every molecule in here needs to be triatomic, which means 3 atoms. They also need to be compounds, which means you've got 2 elements at least in each molecule, and we have that, right? This one has two blacks and 1 white. This one has 1 black and 2 whites, but it's still 2 different elements. And they're all triatomic because they all have 3 atoms in it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that makes that a mixture of triatomic compounds. Next, we have a mixture of diatomic elements. So every molecule, every molecule is diatomic. Told you the vocabulary is tricky. Okay, so they each have 2 atoms per molecule. That makes it diatomic. And it says a mixture of elements, so that means we have to have 2 different elements in here, because that would make it a mixture. If these were all the same molecule, then it wouldn't be a mixture. So we've got the white element here in its diatomic form, and it's mixed in with whatever the dark element is in its diatomic form too. That whole collection means you've got a mixture, you've got more than one type of chemical or molecule in your container, in your object, whatever. All right, so this one said to do a pure substance for water, and I took the time to add little H's and O's just so you could see how this should be represented, okay? So water is, let's mark this up. Water, in case you had forgotten, is H2 oh, so we need to have 2 hydrogens, bang, and bang, right there, and 1 oxygen per molecule. So it's a pure substance of water, so there's 1 water molecule, there's another one. So if this was, a microscopic view of the inside of, let's say, a Poland Springs bottle, Poland Springs is telling you the truth, it's pure water. If this is what you see inside there, it would be the microscope, let's say. There's nothing in there but water molecules. Okay, hang on. And then finally, a mixture of 3 different compounds. So again, answers are going to vary for this one because it's not very specific. It says 3 different, so I knew that, let's get rid of that. So I knew that I wanted to have 1 type, a 2nd type, and a 3rd type. So just for convenience sake, I made my first one diatomic. So I knew that if I used the triatomic for my another compound, that would make it a mixture. Okay, and then I just chose a 3rd type triatomic. You could have done 4 or 5, whatever, it doesn't matter. Just make sure that every single molecule has more than 1 element in it, more than 1 color in it to represent different types of atoms. So that will make all of your molecules a compound. Okay, you need to make sure each type of compound is different from the other types, not the same, and making them different makes them a mixture. So I've got 1 compound, 2 compounds, 3 compounds. That makes it a mixture. That satisfies the 3. Each one's a compound because they have different elements in them, different colors. And that concludes this worksheet. So go over your answers once with this video, maybe twice. If questions still persist, contact your teacher. And hopefully this made some sense to you and the video explanation helped. Thanks a lot. Take care.